Okay, today we're talking about walking and working surfaces, and then we'll tack on weather hazards at the end. So walking and working surfaces is a general industry standard that covers a lot of different things lightly. I mean, I don't mean it's not serious. I mean, they only give you a little bit of detail. And we'll deal with a lot of these topics in the construction standards later. But first of all, let me just kind of skip along. The walking and working surfaces, look at the standards here. It's a 1910 standard, right? It's a general industry standard. Talk about guarding floor and wall openings and holes, fixed industrial stairs, portable wood ladders, portable metal ladders, fixed ladders that are mounted on the side of a tank or in the side of a building. There's some stuff about scaffolding. There's some things about aerial lifts and other mobile equipment for lifting, man lifts, cherry pickers, those kinds of things, scissor lifts. But basically, walking and working surfaces, we're focusing on the areas that we walk and work on a job site. So slips, trips, and falls fit in here to a category to some degree. So slipping and tripping and falling on surfaces. So if you have slippery surfaces, that's a problem. And so you've got to address those. The thing about, and of course, housekeeping, when it comes to having debris or having an untidy job site where there's things to trip on or step over. So when you're cutting up lumber, cutting up pieces off lumber, those trimmings need to be put away into an area. You can't have nails sticking up off of lumber, but you shouldn't have stuff that you can even trip on. So you got to keep a tidy, neat site. That means your regular job site out in the opening, up on scaffolding. You can't keep a whole bunch of stuff that you're stepping over there. You got to keep things organized in these tight spaces too. So there's a couple of definitions. Here's one: leading edge. Well, the leading edge is what they're installing these sheets of corrugated steel decking, and they call them deckers that are installing this stuff. And so the edge that you can fall off keeps changing because they keep adding more sheets as they go. And so they call it a leading edge because it's moving, you know. So they say the edge of the floor, roof, or formwork of a wall or working surfaces such as decking that changes location as additional sections are constructed. They're wearing safety harnesses and they're tied with lanyards to horizontal lifelines behind them. And so they keep adjusting the length of those lanyards, those lifelines, particularly in order to allow them to keep moving along as they're adding more on there. But they're still using fall protection here. This lady's not happy. This guardrail did not prevent what you might expect it should have prevented. If you're going to have some barricades around something, it's not just for decoration. It actually has to prevent people from falling in or and such. And so these are not effective barricades to put around a hole. They have to be secure enough. Guardrails have to be strong enough to support a 200-pound horizontal force pushed at them. And so these don't do that. So around an excavation, this is not adequate to put cute little plastic movable barriers. Not if you're trying to actually keep from being sued from allowing people to fall in the hole. Types of walking and working surfaces, though, door openings too, for that matter. But floors, walls, platforms, ramps, and runways, stairs, ladders, and scaffolding, and roofs. All of these things are examples of surfaces that we can walk on and work on. If you have an opening in a window, opening in a wall, you've got a window, and you've got you haven't installed the window yet. Well, then that's something that you can fall out of, and so therefore, until you've got the window installed, you've got to build a barricade across there. Now that might mean, a standard guardrail system I haven't shown you yet, but it's coming up soon. But at the very minimum, it's a top rail, a mid rail, and a toe board, and the top rail is at 42 inches. Well, think about that when you're looking at a window opening. If that window had, let's say, it started about a little bit off the ground and went up, well, then you might need don't have to worry about a toe board, but you might need a mid board and a top board. top rail. Or that might just mean having two 2x4s, one at 42 inches and one at 21 inches, halfway down. But if your window started up much higher, then maybe you need one piece of 2x4 across there to prevent somebody from falling through that opening. Okay, well, let's move on here. Okay, backing up for a sec. Yes, some types of floor openings. Okay, so floor openings is an important area. We'll talk about them in a couple of areas in this course, but a floor opening is something big enough that somebody can fall through. So yes, if you've got stairs, you've got a stairwell. When you first build the stairs, you've got an opening that somebody can fall into until you've built the railings around the stairs, the balustrades and posts and such. If you got hatches in a roof or trap doors in a floor system, manholes in a street, those are things that people can fall into when they're open. So if a hatch or a trap door or a manhole is open, you've got to protect people from falling into that opening by having some kind of guardrails around it, barricades around it or something. With stairs, that's certainly the case. But if you've got a hole in the floor, that might mean just having a piece of plywood that you screw over top of the hole to keep somebody from falling in it. Now, an opening is bigger than a hole. So let me get the definitions true here. We're going to look at that, I think, in here. Let's see. Yeah, you got to worry about the debris, the litter around you. You got to keep the place clean, keep clear. You got to keep alleyways in a warehouse clear, aisles. You want to make sure they're wide enough to get through safely. You got to make sure that the stuff that you've got in that warehouse or in that shop are stacked properly. So that's something we'll look at in more detail under materials handling and how you stack materials properly. Is here they've got a grease pit that you might traditionally use to change oil in a shop or something. There's covers for this thing. And if the covers aren't on here, then somebody could fall in here. So that's something that a proper shop would have to protect against. You keep them covered, except when there's somebody up underneath. And even at that, you're protected by the car being over top at the time. Load capacities. Okay, well, here's a floor opening. It's a hatch to a trap door or a hatch to a stairway system going down here of some sort. Well, people can fall in there. And so this thing should be spring loaded so that you can't leave it open like this, that it literally close as soon as a person is pushed back through to come in or lift up and go down inside. So, but definitionally, this is an important thing. A floor opening is defined as being where its least dimension is 12 inches or more. So if the opening is 12 inches or more, and it certainly is in this picture, but if you look at this rectangular opening, it's wider on two sides than it is on two other sides, right? So it's longer in one dimension than another. So its least dimension is whatever that is, maybe 22 inches or something. So it's more than 12. So this is a floor opening. A floor opening is something that somebody can physically fall through, or at least some people could. You know, if it's only 12 inches in its least dimension, then it might not be everybody that can fall through there. A bigger fellow wouldn't, and a small, slender person would. So that's a floor opening. Whereas a floor hole is something that you can't fall through. You look at this hole in this picture; it's not big enough for a person to fall through, but you certainly could get hurt by it. Your foot could stick into there to trip you up. If it was a little bit bigger, maybe your whole leg could go in, and that could hurt. So it can typically, yes, maybe if you hit your head because of the fall, it can be fatal. But many times the floor holes, it's a matter of keeping you from falling, by some kind of a slip, trip, and fall. So a floor hole is less than 12 inches, but more than 1. So it's not exactly 12 inches, not exactly 1 inch, but anything in between. Between 1 and 12 inches is considered a floor hole. I like to remember that the word hole has only one syllable and less letters than the word opening. Opening is 3 syllables, and it's a bigger word. Not that big a word, but the point is it's much bigger than the word hole. So yeah, openings are bigger. The word is bigger too. Sometimes those stupid little things help you to remember which is which. I know I need those kind of helps sometimes. So, but anything that's Just up to 1 inch is considered an acceptable gap in boards on scaffolding boards and on decks and things. So up to exactly 1 inch or less is not considered a floor hole or a tripping hazard, even though it's a little bit wide. It's on the line, but as far as OSHA is concerned anyways. Building codes would require you to go much tighter than that. Than that on decking. So it's not like this is going to allow you to have decking that's up to 1 inch in gap. But from the standpoint of safety, OSHA's rules are less strict in some cases than the building codes. So here we finally get into a typical standard guardrail. If there's nobody working down below you, all you need is a top rail, a mid rail, and a toe board. The top rail will be at 42 inches. The mid rail is half of that, at 21 inches. The toe board is down at the bottom, at least 4 inches high, they sometimes say, no more than a 1/4 inch clearance above the floor, so you can't have any gaps more than a 1/4 inch at the ground. 4 inches, by the way, they actually mean a 2x4, which is not 4 inches, it's 3.5 inches. So when you see 4 inches, some places in the OSHA standards, they're talking about a nominal number, the rounded up number. The actual number that you minimum need for a toe board is a 2x4, which would be 3.5 inches instead of 4 inches. Okay, so there you go. There's that. Now, technically, 42 inches is the height to remember. I say remember 42 inches. That's the height. It's a standard height that's going to be above most people's center of gravity. So that's what they use. So that if you were backing up on this thing, it's still going to catch you. But the actual rule is plus or minus 3 inches. So it's really 39 inches to 45 inches. I still say, remember the 42-inch number. 42 inches is what you should remember. Memorize that. You'll need it in many places in your career in construction. It comes up all the time. But yeah, plus or minus 3 inches. But and when it's only 39 inches, when it's 3 inches less than 42, that's fairly low. But what you will find is you go into old buildings that haven't had any kind of a building permit, haven't need to pull a building permit for renovation of any kind. They often have these, they can actually have these very low guardrails that are still allowed because they're grandfathered in by the building code. It's still not a wise idea, but 36 inches is really common in the old days. And if you get up to a 36-inch guardrail, you feel it. It's not right. There's something wild and crazy about 36 inches. And I've even seen some a little lower than that. Okay, so that's beyond guardrails. That's one of the basic forms of fall protection here, So stairway openings, you got to make sure they're guarded by a standard railing on all exposed side except the entrance. And then the entrance should really have a gate, a spring-loaded gate, so nobody can fall down through them. This is true. So the idea that these spring-loaded gates will close when you let go of them is the idea. Ladder floor openings. Here you got a hole in the grading system on this catwalk or whatever it is that you can fall through, and so that's a problem. Wall openings. Here, these look like there may be elevator shafts with no elevators. So they've got a top rail, mid rail, and a toe board, and that is acceptable as protection for you at the top. Now, this is not designed, and OSHA is not trying to prevent toddlers from falling through. That's, OSHA is dealing with occupational safety, not infant and toddler safety. That's for the building codes to take care of. That's for you as parents to take care of, that sort of thing. But is ultimately on construction sites, they don't expect infants and toddlers to be wandering around. And so that's why those rules aren't as strict. But here we are, that's acceptable. But if there's anybody working down below in the bottom of that elevator shaft where your wrench or your hammer or other tool could fall out of your belt while you're working right there at the edge of that opening up top here and smack the guy in the head down below, well, that's not allowed. You'd have to fully screen that in so that nothing can fall. And or the other thing we do if you're working with tools is you tether the tools so that if they slip out, they're attached to a tether. That means they're not going to fall down there. So, but the basic rule here is an opening, if it's at least 30 inches high, and if it's 18 inches wide, the bottom, 30 inches high, where there's a fall of 4 feet or more, then you have to have guardrails or partitions or something to protect people. So this certainly qualifies. It is more than 30 inches high and is more than 18 inches wide, and you can fall more than 4 feet. So all of that's part of this rule. In general, I'm not going to trick you with these rules. There's several different things to comply with in here, and so it's useful to know it exists. I try not to ask you a question about this specifically in that way. But anyways, but you do need to know that including windows and doors and chutes. Chutes. What's a chute? Well, if you can have a trash chute on the side of a high rise where you drop refuge and it goes down through a tube and it lands in a dumpster down below, that's a chute. That's a trash chute. And that's the most common kind of a chute, where you're taking debris from somewhere and you're dropping it through a receptacle of some kind. And so the trash chutes should have doors on them that you have to open to drop the stuff in there, to make sure it's not just accidentally somebody falling through the chute by accident. So it needs a guarded opening. Platforms like scaffolding should have guardrails on them. Their rules actually are that if anything over 10 feet on scaffolding must have guardrails. But sometimes, because maybe the work you're doing on the scaffolding, the work you're doing is you need the guardrail removed. You may have one side removed, and so we call that an open-sided platform. So in general here right now, you do not see toe boards on this scaffolding in this picture. So it's not in compliance. You have a top rail, mid rail, you have to have a toe board so that you can't just accidentally kick a wrench and launch it down to somebody below. Toe boards are required when beneath the opening is on the side, you got a person can pass, or there's moving machinery, or there's equipment where falling materials could create a hazard. Okay, there's that slipping and sliding again, a picture. I'm going to skip some of this stuff because I'm trying to get to the key stuff without taking too long in this presentation. But stairs, we're going to deal with stairs in a lot more detail, but a couple of things that can show up here early on in walking and working services is just the basic stuff about stairs. And that is that any break in elevation of 19 inches or more requires a step or a riser for you to step up. And so then you need stairs or a ramp, but usually it's stairs. So stairs consisting of 4 or more risers, or a overall climb of 30 inches or more in height, requires a handrail for you to hang on to. So that's the one that definitely could show up at a test question near you soon. And that is stairs consisting of 4 or more riser heights, or those 30 inches or more in height overall, require a handrail. I think I've got a picture. I don't know if it's in here about this. I guess it's in another section now that I think about it. But so what happens is each step from the ground up to the first step on this set of stairs, that's a riser height. Normally that's a 7-inch height, ideally. So every 7 inches up would be a riser height. Well, so whatever number of steps here, when you've reached 30 inches, then you definitely must have had a handrail to hang on to. So if the top platform is only 30 inches up, well, you're still going to need a handrail. But if you've got 4 risers that are normally 7 inches, when you do 4 risers, that's 28 inches. So even before you get to 30 inches, when you get to 28, you would have to have a guardrail there for for that platform. And of course, here it's way higher to the platform. That platform at the top of those stairs is much, much higher than 30 inches. It looks like it's maybe 80 inches or something, maybe 90. There's some beat up old stairs. Yeah, all stairs in general are designed to carry 5 times their expected load, which would be a minimum of 1,000 pounds. And with OSHA, the minimum width of those stairs, the width of them, the path for you to walk through here on these stairs, is just 22 inches. Now, in the building codes for residential, it'd be 3 feet. And for commercial, it could be wider than that, depending on how many people are going to have to go down those stairs. But 22 inches is not a very strict rule for width. But in general, most things, we make things 4 or 5 times stronger than they need to be in order to make sure they don't break. We have safety factors built into things and that's normal fare for your step ladder, your straight ladder, floor systems, and everything else. Ladders used to gain access to a roof, to climb up and go somewhere else, to leave the ladder. They've got to extend at least 3 feet above the point of support. So you need to have at least 3 feet sticking up. Now, this ladder here is not a straight ladder. Well, it looks pretty straight. No, we call that a step ladder. You're never supposed to use a step ladder to climb up, to go and get up onto a roof or onto some scaffolding or onto anything else. You're never supposed to leave a step ladder any other way other than from the bottom at the ground level. So you can climb up a step ladder, but you're not supposed to leave the step ladder. You're supposed to climb back down and get back on the ground. Part of it is the magical ability of those back legs to walk your ladder away from the wall. And step ladders don't generally have pivoting feet to contour, to have traction. So they're meant to be self-supporting, self-standing ladders, not to be leaned up against. Never climb a step ladder this way. You'll get halfway up and that ladder will slip out from underneath you and you'll be taking a fast ride to the ground. You're always supposed to face a ladder where you're going up or down, using both hands and both feet. That means you can't be carrying anything else in your hands. They talk about 3-point contact with ladders, where you've either got 2 hands or a foot, or 2 feet in the hand and 1 hand, but it means you're alternating as you go up, and therefore you're not supposed to be carrying anything with you in your hands when you climb a ladder. I know I've done it before myself, but you're not supposed to. So you need to know what you're not supposed to do. But in general, this 3-foot rule is true for ladders, that you're supposed to leave the top 3 feet of a ladder for other uses, not for climbing, not for standing on. So here we're looking at a simple straight ladder. It's not even an extension ladder. It's apparently 20 feet long, and it's leaned up against a building. That's apparently the height of that building up to the top is 16 feet. We're supposed to keep ladders at a 4-to-1 ratio for the slope. So for every 4 feet you go up a ladder, you're supposed to pull the ladder back a foot. So the closest thing to a math question in this course is to understand this concept in order to project it to, if you know you're going up 16 feet, how far do you need to pull the ladder back? Well, this picture shows 4 feet. Well, that's just basically 4 times this ratio, a 4-to-1 ratio. If you multiply both numbers by 4, you get your answer. So if 16 is 4 times higher than 4 feet. So that's why you need to pull the ladder back 4 feet. Now, this makes a right triangle where the ladder is the hypotenuse, the long side of a right triangle. So if it's 16 feet up, then the length along the ladder from the ground along that ladder up to that roof is longer than 16 feet, right? So you can't use a 16-foot ladder to climb up 16 feet. You need another 3 feet to have something to hang on to stick up. Well, that gets you to 19 feet, but you're also losing 3/8 of an inch per foot of climb. So 3/8 of an inch times 16, well, I don't know. That's a few inches anyways. So my point being is that you're losing height of ladder because of it running along the hypotenuse instead of being straight up and down. You're losing 3/8 of an inch per foot of climb, of overall height climb. So that's another rule to remember in here. A lot of this I'm giving you is extra than what you need for this chapter, but we'll be dealing with this when we deal with ladders, stairways, and scaffolding soon. Fixed ladders that are mounted straight up the side of a building or on the side of a tank or something, we call them fixed ladders. They typically will have cages or a well like you see here. That's an important safety feature too. They are much harder to climb. That 3-point contact is not really true. You've got to have pretty much full 4-point contact. Maybe you're always going to have 2 hands on there as you go. You're just not going to stand long. It's not so easy to stay on one of these things. Okay, scaffolding must be capable of supporting 4 times the maximum intended load. So again, there's that 4 times and 5 times numbers. 4 times is used a lot in scaffolding, 4 times the expected load, and in ladders. Okay. Never alter or move it. Never alter and move scaffolding while somebody's on it. You protect the workers and scaffold from overhead hazards, and you've got to, if the scaffolding is higher than 10 feet, even a smidgen higher, then you must use guardrails, midrails, and toe boards. Now, I've got some scaffolding, and I've had it at 10 feet, exactly 10 feet. And that's really, even at 10 feet or even before you get to 10 feet, you should really have guardrails. But so OSHA has this minimalist number, but then they require fall protection if you're working above 6 feet. So they still require some kind of fall protection. So they have competing rules is what happens. And so long before you get to the 10-foot rule for scaffolding, you need to know that 10-foot rule for a test question, but you're going to want you're going to want guardrails or some form of fall protection. You could be up there without scaffolding, without guardrails if you had safety harness on and you're tied off to something tight enough so that you can't fall any more than 2 feet before it kicks in. You gotta make sure the wheels are locked before you climb up on this ladder, on the scaffolding, I mean, or before you start disassembling that scaffolding or assembling it for that matter, if you've got wheels on it. So here's some wheels on it. Horrible, horrible situation here. Oh my goodness. Crazy. OSHA would have a conniption over this. So it's a funny picture. Yeah, there's no such thing as OSHA approved patio chairs for supporting scaffolding or chunks of concrete being used to sit a scaffolding up on wheels, no less. Anyways, and then there's that funny picture. That's a team belt scaffolding system. Hey, that doesn't work well. Okay, well, let's see. Roofs. Wear boots or shoes with rubber or crepe soles that give you good traction on that roof. Always wear fall protective devices, even on shallow pitched roofs. Rain, frost, snow are all dangerous because they make a roof slippery. I can remember having to put shingles on an icy roof up in Canada where I grew up, and taking a propane torch, tiger torch out there, and to try to defrost the roof to get the ice, the skim of ice on the roof off melted so that we could finally start putting shingles back on that roof. It was hard to stay on that roof with ice, let me tell you. You should be worried about the granular nature of a lot of roofing shingles and roofing materials is that it makes slippery little ball bearings of sand that can be sprinkled all over your roof. So you got to brush or sweep that roof periodically to remove any accumulation of the dirt and debris from the shingles or what other materials are like that. Or else you'll be self-cleaning that roof, including the roofers. A warning yarn. Okay, sorry. Warning yarn is another thing. A warning line is required at least 15 feet from the roof edge. This is as part of a system, a type of fall protection system where when you're closer than 15 feet, you need to be tied off in such a way that you can't fall. And this would work on a gentle slope roof, a low slope roof, we would call it, where you have a controlled decking zone. And that's really what they're talking about in number 5 here. We'll talk about a controlled decking zone in a lot more detail later, but if you see something about a certain distance horizontally from the edge of the roof, a warning line, that's part of a controlled decking zone that you warn everybody that once you cross this line and you're now closer than 15 feet from the roof, you have to tie off with a safety harness or have some other form of fall protection. Whereas when you're beyond that, you're far enough from the edge that you could maybe wander around that roof without a safety harness on. Okay. Pitched roofs, you install necessary roof brackets that helps to keep you on the roof. It helps to keep material on the roof. That's acceptable, but it's not a fall protected device per se. So here's an example. This one's a 12-12 slope, is about a 45-degree angle. And they're rechanging the roof out on this roof here. And they're actually nearly done. They're 2/3 done on this side anyways. But no real fall protection at all. You know, there's ropes that were tied to the peak that they would hang on to. And they have these rubber cushions that you see here in this picture. And they really do help to keep you on the roof, but they're not a safety device. They're not something as you can call a fall protective device. But again, like so many jobs, they can do the wrong thing but still survive, and that happens a lot with roofers. Every now and then, a roofer falls off a roof, or somebody falls off the roof and they never can climb a roof again. They're lucky if they can walk or if they survive. Depending on the type of injury, a worker who is trained in first aid should evaluate the injured and decide the best treatment. And oftentimes that means going to a hospital for professional medical treatment. Now we're finally dealing with weather hazards. So here, a lot of ways we talk about this is heat stress in hot weather and cold stress in cold weather. So in Louisiana, the heat stress is the bigger deal. Now, I have to say that, yes, I've been in and gone and spent lots of time hiking and exploring in 30 and 40 below weather and having fun cross-country skiing and downhill skiing in that kind of weather. And it's great if you've got the right clothing and you know what you're doing. But I tell you, I think I've been colder here than in Baton Rouge. With the humidity we have, it bites through. And so that, I used to be able to go out jogging in 10 below weather up in Canada in shorts and a t-shirt if I built up enough heat before I left the house and just keep working, as long as I didn't stop, build all that heat you're generating by jogging. In Louisiana, you got 20 above and you got to put all the clothes you got on. It's just bites through. The humidity is something. But you're still not likely to freeze to death here. I don't think. I just don't think that happens very much. We get hypothermia and go to sleep and wake up dead. No, here the big deal is heat, and it is particularly because of the humidity. And why is it? What's so bad about humidity? It's just that our bodies, we cool off by sweating. Our sweat coming out of our pores as it evaporates cools us off. It's like a human swamp cooler. And it works. And it even works in this humid environment because, water still evaporates off your skin, just nowhere near as fast as it would in a dry climate because there's so much moisture already in the air. So it takes longer for clothes to dry on a clothesline here in Baton Rouge than it does in Arizona, in the same temperature. Okay, let's leave this page here. Yeah, so yes, we have to worry about other kinds of weather hazards, tornadoes and floods and lightning, but we're mostly talking about heat and cold here, the two extremes here of this chart. So there's no specific standard in OSHA standards for dealing with heat stress and cold stress. They have some requirements for the employer that show up. And that general duty clause that I've talked about on the first day of class here, that general duty clause is the most commonly cited thing for dealing with heat stress and cold stress. The employer has a responsibility to make the job site safe, and that includes dealing with the heat and the cold. So when it comes to heat, that means having plenty of fluids, having more breaks when it's extremely hot, in the shade, not just breaks, but in cool down sessions, cool down stations, those kinds of things. You got to protect your workers. The right kind of gear for dealing with that too. So if you're going into a very hot tank or something, you might have to wear a special vest that helps cool you off, that maybe has ice packs in it, or at least water vests of some sort. The hazardous communication, it was right on the page if I would have looked, but hazardous communication standard is 1910-1200. So I don't expect you to have to memorize these numbers. There's only two numbers that I want you to memorize in this course. One is the General Duty Clause, Section 5A1, and the Whistleblowers Law, Section 11C. So employees have a right to know about the hazards regarding heat stress and cold stress exposure, and so that falls under Section 11C. And in also, if they complain, you can't. In that sense, you can. If the employees complain about something related to this, then you can't dismiss it. You can't punish them for or retaliate against them, and that'll come under Section 11C. But Section 5A1 would be something that the OSHA officer could easily use to against your company as a citation for not providing proper protection for employees in heat stress and cold stress. So that generally would happen if you end up with somebody in the hospital with heat stroke or heat stress even. That's likely that OSHA would issue a citation for that, and that would probably be the 5A1 general duty clause. Okay, so yes, there's heat stress in terms of heat cramps, muscular pains and spasms, heat exhaustion, when the bodily fluids are lost through heavy sweating. And of course, what you can do then is not be able to sweat anymore at some point. You can get that bad. Heat stress occurs when abnormally hot air and high humidity or extremely heavy exertion prevents the body from cooling itself off fast enough. So there's these diminishing returns where you're just overheating and you're not able to cool off as fast as you're heating up. Whereas the extreme case would be heat stroke, where the body temperature control system just basically stops working. So if you can't keep bodily fluids down, you can't drink water, you can't replace the water, you're going to need an IV. You can't, if you're vomiting it up, you can't keep it down, you can't drink water, you're going to need medical attention. And that's going to turn that into a recordable event for your OSHA records, your safety record. But that said, that's the least of your worries. If somebody gets heat stroke, they can die. They can have serious damage, brain damage, just like any stroke. The heat stroke can do that very thing. Okay, so there we're looking at the definitions there. Cold stress, on the other hand, there's frostbite is one of the big things, and frostnip would be the early stage of frostbite. So what is frostbite? It's where your flesh is freezing and being killed by the freezing action. What happens is when water freezes, it expands. And so when water freezes in your flesh, it's expanding and tearing apart the cells in your flesh. So it's killing the flesh. Your flesh actually turns black. If you got, depending on the pigment in your skin, it's going to be a very darker color. One way or the other, it's turning darker. Frost nip is more of a grayish or a lighter darkness. And so it's in early stages of frostbite, and generally means that you're not going to lose fingers from frost nip. You may have some scarring from it, but you're not going to have losing fingers. But that's generally what you lose in frostbite is fingers, earlobes, end of your nose, cheeks, the parts of your body that are exposed, but generally your abdomen will be the last thing to go. But you see now the third thing on the list on this page is hypothermia. Okay, hypothermia, life-threatening condition caused by the exposure to very cold temperatures. The body eventually, your shivering is a natural thing where our bodies do in order to move around and build heat. But when you stop shivering and you haven't gotten any cold, any warmer, that means your body's given up, and you're going to want have this severe desire to just rest and go to sleep. And that's a bad thing. So in that sense, hypothermia, you go to sleep and you don't wake up. Hyperthermia is a similar sounding word, but you see it down there at the bottom. It says, whereas hyperthermia is a life-threatening condition caused by the exposure to very warm temperatures, the body produces or absorbs more heat than it can dissipate. So hypothermia is the opposite of hyperthermia. Hypo is cold. So the word O in cold and O in hypothermia helps you to remember. I don't know. You got to remember something, but hypothermia is the cold weather. Hyperthermia is the hot. Okay. So I've got a lot of pictures in here that are interesting, but I think that I can kind of skip past a lot of this stuff. I guess understanding heat exhaustion, you can get moist and clammy skin, pupils can dilate. Whereas heat stroke, your skin stops sweating. When somebody stops sweating and they haven't really stopped having trouble, that's a seriously bad sign. Pupils constricted, looking more like Lieutenant Commander Data on Star Trek. Well, that's also indication of stroke. And there's some other things too, of course. They're babbling nonsense. That's a bad sign. Yeah. So yes, I've got a lot of extra information about the relative humidity and how that affects things and all that. And on the cold side, I did want to show you a little bit about the cold stress because in Louisiana, most of you know as much as I do about heat stress, because you've dealt with it. If you've worked in construction at all, or if you've worked outside in lawn care or anything like that, roofing. But in cold weather, part of it is you dress in layers. And sometimes in Louisiana, we don't know that because we're not outside that much in cold weather. There's only I can usually count on one hand how many extremely cold days that are really worth worrying about. And there's been less of them in recent years. I can't remember. I remember a couple of years ago, a major week that was bad, where we lost power. So that's why I remember it. And we're freezing our asses off at home. But anyways, I wanted to show you something about frostbite here. So like this is a cartoonized picture showing you frost nip is in the grayish, and so if you've got very light colored skin, then yes, you see a grayness to it. You'd still see a graying hue with more pigment in your skin. But yeah, so the gray is frost nip. When you see blackness, that's dead flesh. It's very serious, of course. So you never rub the skin when you're dealing with this. That's not how you warm up. You know how you naturally want to warm up your hands in cold weather, and that's a neat trick when your hands are not in trouble and your skin has not been frozen yet. But rubbing skin that's frozen is going to peel off flesh. It's make it much worse. So these are some ugly pictures, not as ugly as what I had in the PPE section here. But frostbite, you're seeing it in the ear here up at the top. That's frostbite. These fingers on the right side, the lower right side, that's frostbite. But the center bottom picture is showing you a classic version of frost nip. There's a little bit more pigment in the skin here on this hand, and it's showing you some darker skin, but it's not necessarily frostbite yet. It hasn't turned dark enough to be that. So you're not likely to lose fingers in that condition. But I want to point out another thing. You see the blisters on the hand over on the very left-hand side, and the blister on the cheek up at the top center picture. That happens when you try to warm up your skin too fast. When you got really cold skin out in cold weather, you can't take really nice hot water out of a sink and wash your hands to warm up. Yes, it'll warm up your hands quickly. It's too quickly. If you've ever noticed when you've got cold hands and that even cold water can feel warm, that's what you need. You start off with cold water that feels warm because it's still a lot warmer than your hands are. And that's less of a temperature differential. The temperature differential is what gives you a burn when you touch a hot burner or something and you get a blister on your hand from a burn. That's the skin separation that's happening from the temperature differential. You will feel and experience the same pain from the same kind of burn by taking what would normally be acceptable hot water on your hands when your hands are cold. Okay, so yeah, I got too many pictures in here. I'm going to go along and call it a day here, I guess. But look at that. This is on the water, I think on the East Coast, where there was some weather that came in and just coated those cars in ice cold ice. Yeah, the antennas, a chubby column. So what they normally do to thaw this out is use calcium chloride. It's a type of a salt that works better for something like this. Of course, then you need to rinse all the calcium chloride off the vehicle afterwards. Okay, so beyond that, yes, I have a bit of a summary here. Again, even the trash chutes need covers, protective doors with little locking mechanisms to make sure that nobody's going to accidentally fall through there. You got to pull this thing down to drop the trash in there instead of just throwing it in there, because a person could ride that thing down and be hurt seriously. Always face a ladder when you're climbing it or coming down. Fall protection is necessary even on shallow pitched roofs. On pitched roof, that means steeper roofs, you may install tow boards to prevent falls. Open-sided platforms are those without guardrails. Ramp and runways have similar hazards as those of floors. Let me back up to the first page for a minute. Loose materials would be considered a floor hazard that you can trip on. Okay, I'm just looking at the red stuff in here. Okay, so page 3, let's see, of the study guide, your little summary here. It's not really a study guide. I've got a lot of this stuff in the official study guides in the course too. But when working or walking on scaffolding, use only approved scaffolding. You keep the scaffolding plumb and level, keep tools and materials away from the edges, lock the wheels before assembling or disassembling the scaffolding. So the stuff in the red is the most important stuff. First aid performed on a job site should only be performed by those trained and certified. That said, it's not a bad idea for you to have first aid, CPR, AED training when you work in construction in general, and especially if you're involved with safety. But generally, anybody involved with management has a particular responsibility for safety. That's why it's part of my construction management degree program. And there you go. Even the dog is dressed up with blanket here to stay warm.